Welcome to my channel Chemistry Not Mystery. You can also visit my website chemistrynotmystery.com. This is the first lecture of thermodynamics, and in this lecture we are going to study types of system, extensive and intensive properties, state functions and path functions. So let's see, why do we study thermodynamics? It helps us to understand heat and work interconversion and enable us to predict the feasibility or spontaneity of a reaction. But what do we study in thermodynamics? Therm means heat and dynamics means in motion. So heat is always in motion between system and surrounding. But what do you mean by system and surrounding? So let's see. For example, if we are going to study these molecules in this container, so it is a part of universe that is under observation for study, is known as system, and everything around the system is surrounding, and the walls of the container that separates system from the surrounding is called as boundary. The universe includes system and surrounding. So there is always exchange of matter or heat may take place between system and surrounding. So on the basis of it, system can be classified into three categories: open system, closed system and isolated system. So let's see how they are different from each other. As you have observed here, in open system, matter can exchange between system and surrounding, and heat also may exchange between system and surrounding through the wall of the container. So such type of system is known as open system. But when you place a lid over this open system, in this way you have stopped the exchange of matter between system and surrounding. But still heat may exchange between system and surrounding. So such type of system is called as closed system. But when you place an insulated jacket over this system, in this way you have stopped the exchange of matter as well as heat between system and surrounding. So such type of system is known as isolated system. Every system has some properties. These properties may be extensive or intensive properties. Extensive properties are those properties whose magnitude depends on the amount of matter present in the system. For example, mass. If system contains less amount of matter, it weighs less, while if it contains more amount of matter, it weighs more. Volume is another intensive property. Now come to the intensive property. Intensive properties are those properties whose magnitude is independent of the amount of matter present in the system. For example, molecular mass. If you take a glass of water, this 1 liter glass of water, and if you take 2 liter glass of water, in both the cases, molecular weight of water will remain 18 grams per mole because it is independent of the amount present inside the system. Boiling point is also an intensive property because the boiling point of 1 liter of water is also 100 degrees centigrade and boiling point of 2 liter water is also 100 degrees centigrade. Extensive properties are additive. That means you can add them. For example, volume. If there are 2 glasses of water, both having 1 liter volume, when you add them, you will get 2 liter glass of water. So in this way, volume can be additive. But intensive properties are non-additive. For example, boiling point. if we take the example of boiling point for the same example, when you add 1 liter glass of water, it results 2 liter glass of water. But the boiling point of 1 liter as well as 2 liter both are 100 degrees centigrade. Here you can see boiling point is non-additive. That's why it is an intensive property. The ratio of two extensive properties is an intensive property. For example, density is equal to the mass over volume. Mass and volume both are extensive properties, while density is intensive property. If you want to define the state of the system, you have to define its temperature, pressure, volume, and number of moles or the mass of the matter present in the system. So these properties are known as state variables. Set of state variables define the state of a system. For example, this is the initial state, and after heating it reaches to the final state. Now you have to define the initial state. To define the initial state, we can take this temperature T1, pressure P1, volume V1, and N1 is the number of moles present in initial state. And after heating, it reaches to the final state, and the state variables for the final state will be T2, pressure P2, volume V2, and number of moles will be N2. So these set of state variables define a particular state. When you change any state variable, it also changes the state of the system. Every system has some thermodynamic properties. That properties may depend on the path followed by the system to get that final state, or it may be independent of the path followed by the system to reach the final state. So these thermodynamic properties can be classified into state functions and path functions. State functions are those properties of thermodynamic system whose value depends on the current state of the system and independent of the path followed by the system to reach that state. For example, temperature, pressure, volume, or mass. For example, when you increase the temperature by 10 degrees centigrade, so final state of the system will gain 10 degrees centigrade more temperature. But it doesn't matter by which means you have increased the temperature. So that's why temperature is a state function. Now come to see what are the path functions. Path functions are those property of the system whose value depends on the path followed by the system to reach that particular state. For example, work and heat are the path functions. Let's take another example to understand what are the path functions and what are the state functions. For example, here both guys want to reach to the top floor, but one took the stair and other took the lift. This way, both had reached to the top floor, but the potential energy depends on the initial and final state, not on the path taken by the system to reach that state. Potential energy, as you studied under physics, potential energy is mgh. So potential energy is directly proportional to the height of the object from the ground. So in this way, both the guys will have the same potential energy and it is irrespective of the path followed by both the persons. While the work done by both the guys are different. The one who took the stair has done more work as compared to the guy who took the lift. So here, work depends on the path taken by the system to reach that state. So that's why work is a path function, while potential energy is a state function. I hope now you understand and you will be able to answer this question. The volume of gas is reduced to half from its original volume. The specific heat will be reduced to half, be doubled, remain constant, or increase 4 times. So here, first you have to check whether the specific heat is an extensive property or intensive property. Is it a path function or is it a state function? On the basis of that, you will be able to answer this. And you have to post your answer in the comment box. If you have any doubt, you can post them in the comment box. And don't forget to like and share this video. And please subscribe to my channel and press the bell icon to get a notification. You can also join my Telegram channel or follow me on Twitter or Instagram. Thanks for watching. Keep learning.